Thank you very much, Frank. Yeah, okay, now you introduced me already. So hi, everyone. My name is Sören. So like Frank said, I have been using FME for about 7 years and spent most of my time at Conterra working on Inspire stuff. So I do a lot with OGC services, XML, GML, so topics that are probably not that hot in Canada. So I thought today I'm going to talk about something else. There's another project that I've been working on 1 year ago. So as far as I'm informed, you get a lot of snow here during winter time, and we also have some regions in Germany where we also get a lot of snow. So I'm going to talk about the Bavarian road weather platform, also called Winter Maintenance Management System. It's a system that we developed with the use of FME Server to support the local road authorities in Bavaria to keep their roads free of ice and snow. And we use different data sources to do this. So first of all, I'm going to give a brief introduction to the road weather platform, the different data sources that we integrated. Then I'm going to explain what is happening in the background. So I'm going to talk about the architecture and the role of FME Server. So how did we use FME Server to solve all these complex challenges, to integrate all the data, the weather data, the sensor data to make the system work. So the development for this project started in 2015 and is by now used by about 50 local road authorities in Bavaria. It's a central platform for the Bavarian road administration to manage and optimize the winter road maintenance. The Winter Maintenance Management System, it's quite a long name, I should come up with a shorter form, is used to coordinate about 1,400 service vehicles to keep traffic moving on Bavaria's more than 22,000 kilometers of road. So the goal of the platform that we built there is to integrate all the necessary information that the authorities can use to coordinate their vehicles. And this is basically data from different data sources that help them to do this. So we have data from the German Meteorological Service, the Deutscher Wetterdienst. We have data from MobiWorks and METS. They provide real-time information from all the snow cleaning vehicles as they move along the roads. It's not only the information about the position, it's also information about what they are doing currently. So if they are plowing at the moment or if they are gritting, so we know exactly what they are doing. And then we have sensor data. So there are a couple of hundred sensors on the roads that measure the road temperature, the air temperature, the dew point. And then we have webcams. I mean, this is not done with FME Server, but it's also interesting information where the people can see how the road actually looks like. We have the tour plans, so the routes that the vehicles usually take when they do the gritting and the plowing. That's also quite interesting. We have thermal data from sensors on vehicles. So there are some special vehicles that they send along the roads to measure the temperature or the distribution of temperatures where they don't get continuous information, but then they use the values from these drives to actually calculate, or we do it on FME Server to calculate the temperature or to improve the temperature model that we have at these points so that we know even on places where we don't have sensors, we get better estimates how the temperature there might look like. You can see this here on the right side a little bit. Like the red roads are basically the ones where you might have ice or snow, and the green ones are the ones where you don't have to worry. This is more about the temporal extent of the data that we are using. So the system is basically integrating data for the past 2 hours and the coming 18 hours. For the past 2 hours and the coming 2 hours, we have a temporal resolution of 5 minutes. So we have like the rain data, basically the rain data, the precipitation radar data for the next 18 hours, and then webcam images, weather reports from the German Meteorological Service. We have the thermal data along the roads, the planned routes, and then we also get regional official warnings for the routes. Okay, so let's have a look at the architecture, or a bit more detailed on the technology stack that we are using here. So on top, we have Map Apps, which is a Quantera product that's based on Esri technology and helps you build interactive maps and integrate lots of different services so that the local road administrations can use it and see immediately the information they need to know. Then we have ArcGIS, where we have all the feature classes and the map services and the data that we collect with FME Server to provide these maps. So there's so there's a time-enabled Esri geodatabase. So each feature has a temporal extent for that it is valid, and then we have this time slider in the application where the service guys can then move along and see how the weather will change in the coming 18 hours, and also how the road conditions might change, where they might get ice, where they might get snow, and so on. And on the very right side here, we also have the real-time component, which is still under development, where we store the positions of all the vehicles in real time. So there we have like a temporal extent of 1 minute. So we have the positions every 5 seconds, but we only update them every minute. Yeah, and so of course, as you can see on the bottom, the biggest role in this system, or most of the work, is done with FME Server. So we have many different formats that are integrated from different kinds of services. So the weather warnings are provided, for instance, as OGC WFS. We have the tour info plan, the tour plans that come in as map info data. We have thermal data that contains measurements of the temperature along the routes that come in as CSV files. We have the stations data, also CSV files that come in from an FTP. We have it's quite an interesting format, the GRIP2 Cosmo files, which is a meteorological format. I used it the first time in this project, so for me it was very interesting. I don't know who of you has ever used GRIP2, but yeah, that's something I found very exciting, and it's also one part of the project that I want to show a bit more. So that's the workspace I'm going to show afterwards, what we did there. Yeah, and of course we have the real-time data here, which comes in as XML files, so that we know where the trucks are at the moment. Yeah, and also you can see that the information is updated quite frequently. So we have, for some sources, there's an hourly update, like for the Cosmo data. Then we have things like the warnings and the sensor data that are updated every 15 minutes. And then we have the real-time data, as I said, that is updated every minute. Okay, let's have a bit more detailed look on the GRIP data. So this is the one that I found very interesting. So GRIP2 is a format that is used, as far as I'm informed, worldwide by meteorological services. It provides binary raster data. It can have hundreds of bands, and in our case, each band represents a different temporal extent, or not temporal extent. So it shows at a certain point of time how the rain or the rainfall was distributed at that moment. So the workspace that we use, or that is executed every 15 minutes, then is this one. So I'm not going to go into all the details. So first of all, what we are doing is we have a Python creator that just gets the files from the FTP. It just gets a list of files that are there. Then we have a feature reader here that reads the GRIP data. So we just get a list of files. We select the newest file, and then we download it. Then over in the middle bookmark, so the next one is just the terminator if something goes wrong. In the middle bookmark, we select the bands we need. So since like I said, there's hundreds of bands in the script file, we only need a few ones because we only need the temporal extent for the past 2 hours and the next 2 hours. So we only have to select a number of bands. So we have a published parameter where we put all the bands that we need. I mean, this is just a private parameter. It's not put in by the user. It's all done automatically on FME Server, but we have to put in once the bands that we need. Then we use a raster band separator where we select the bands, and finally this goes to the raster selector first we select the band, and then we go to the raster band separator so that we get out separate images or image files that we then write out as TIFF files, and these TIFF files are then put into the S3 geodatabase using ArcPy again. There's maybe one more interesting thing that we are doing here, because we only get cumulative rain inside the files, so we have to subtract all the past rain from the raster bands so that we get the actual rain. This is done in the raster band calculator down there. So we just do a minus operation with the ones before so that we get the current rain in each TIFF file. Okay, so this was the workspace. I think another thing that's maybe also interesting is something that we are still working on, or that is still currently extended, is a real-time data extension. So we are collecting and storing the real-time data of 1,400 snow trucks as they move along the roads every 10 seconds. So this can be in a busy night during winter. This can be 10 million points per day. So it's quite a lot of information. So at the moment, we only put this data for 1 day in the system, and then it's overwritten by the newer data. But the plan is to use a big data store from S3 so that we can keep this information for a whole year, so that we can go also back and see where the trucks were going, where they were gritting, so that we know if there was an incident, if the streets were cleared, and the kind of things like that. So from the FME server side, this is not really a big problem, so we didn't get any problems with this amount of data, since we only get the additional positions every minute. We don't have to put in like 10 million points at once. We just query the server for the updated positions and then put them into the geodatabase. Okay, I'm just seeing if I forgot something. No. Yeah, as you can see, we make heavy use of FME server schedules. This was also in the beginning one of the things where we thought, okay, maybe we will use notifications and then somehow chain the jobs, so that whenever we have an update, we then start the next job and do this. But we found that it was easier and more stable, more robust with the schedules, because once the job before fails somehow and doesn't notify the next one, it's easier with a scheduler. And also if there's like many jobs queued, you can just tell them, okay, don't stay in the queue longer than 15 minutes. So this was really easy. We didn't have we didn't get much trouble with the scheduling. And as you can see, it's quite heavy use. So there's 2,000 jobs running per day. I think the system currently uses 2 or 3 engines, I'm not sure. The screenshot here is just from our development system. So not all the jobs are currently enabled. Normally they are all running. And as you can see, we already reached almost 1 million jobs on that machine. So it's now been running for almost 2 years. Every day, 2,000 jobs makes almost 1 million. Finally, I'm going to show you a bit how the solution that we built on top of that, so the actual application that uses all of this data that we process there looks like. So I showed you already a bit in the beginning. Actually, can you see my mouse here? Yeah, maybe it's easier like that. So as you can see here, we have stations along. These are the sensor stations that show the current temperature, the dew point, and the surface temperature of the road. We have the roads. In green are the roads that are neither icy nor covered by snow. Then we can select one of these stations and can also see more details for the past 2 hours and the coming 18 hours. So everything after this line here is prediction data. So you see the temperature of the surface of the road, the outside temperature, and you can see here also if it was raining, if there's snow or ice on the road. So the system automatically has a model that calculates if that will be snow or not. And the most important one where's the mouse again? It doesn't matter. The most important one is a red line down there that actually gives you information about the condition of the road. So if it has to be salted or plowed, if there's snow, if it has to be cleaned. And the last one is the wind Okay. We also have a. I'm looking for my mouse. It's here. We also have this time slider application, so that you can basically just click play, and then it will, like you know from any weather forecasting sites, show you how the rain is moving, how the condition of the streets are evolving over time. You can open up the webcams for the different stations so that you also can visually control if it's actually snow in that road or not. So, I mean, the system is nice, it shows you a lot of information, but sometimes it's just better to control using the webcam. Okay, yeah, this is a real-time application where you can actually see the snow trucks moving around. You see if they are currently clearing the road, if they are putting down salt, if they are driving or standing, how long they didn't send data or when they sent data the last time, and you can see them also on the map and which routes they are at the moment clearing. I think I have a bigger one of that, yeah. So sometimes you have them in positions where they can't send any information, like if it's a very mountainous area or the weather conditions are so bad or they don't have mobile connection, then it might be 1 or 2 hours that they don't send any position, but normally they send their position, yeah, like I said, every 10 seconds. Okay, so yes, so this is more like some feedback we got from the other guys who were working on the project. I was only working on this project in the very beginning, so it was also really nice to hear from the other people in the project, mainly the customers, that it was really, that FME Server really out of the box solved most of their problems. So we had lots of different formats, even some exotic ones like the GRIP2 data that were immediately working in FME Server. So we had processes for vector and raster data, and we had the powerful scheduling engine, so everything we needed was right there, even if it was quite a complex system. I just put in all the formats that we were using here on the right, just to remember. So we got a lot of good feedback for FME Server here. It is one of the core pillars of the system, and it really made it easy to extend also the system. So it's a system that we are still working on constantly, even if it's already in production. So like the real-time part is being added, and also we try to improve the models that calculate when there was snow or ice on the roads. And of course all the processes are continuously extended and optimized. Yeah, that was my presentation. Hope it was interesting for you. Don't know if there are any questions.
Let me bring the mic over to you.
Sorry, yeah.
Sorry about that.
Okay, I'd like to know if you make the data, publish data for the general public as well?
No, because some of the data is like from commercial providers, and also the positions of the vehicles, for example. There's also privacy issues with the driver, so we can only take the data, for instance, as long as they are really plowing on the actual routes. So there's different reasons why this is not possible. No. I mean, I think the information from the German Weather Service might be available, but not all of the data. Okay, yeah.
So in Iowa, we actually push all of our data out and open, including the snowplow data. But I had, so like do you have a vendor for your forecast data, or is that calculated yourself?
Sorry?
Do you have like a vendor, like weather service sort of provider for the data, or do you calculate?
We have the forecast data for the precipitation, the rain, and these kind of things from the German Meteorological Service. But the temperatures of the roads, we use that information to calculate them ourselves.
Okay, so you do that, so you calculate some of that. And then if you have a vendor, what's the need to create your own sort of radar service of these FMEs to pull the data in? And
because to show it in this application, I mean, this application, you have to imagine it's running like in the rooms where the guy who coordinates the drivers is sitting, and there's like a huge screen where this is constantly running all day. So he really uses this to coordinate the drivers, and they only need like certain time slices out of the.
Oh, so do they not? Is the data not provided as like a REST service then, or
Sorry?
is the data not like in a REST service of where you can just throw it into like ArcGIS?
No, the data that comes in from an FTP service, and it's just single grip files. So to have always up-to-date data, we have to go there every 15 minutes, grab the newest file, and then also to always have the best forecast data.
Okay.
Next person, question? Okay, well, I have a question.
Soren, can you tell us a little bit about the image you have on screen?
Ah, yes. This is actually a very nice camping ground in Estonia. This is where I spent my last vacation. And this is also where I proposed to my new wife. Yeah.
Okay, so we'll wrap that up. Thank you so much, Soren.
Thank you.